Welcome back to the channel. Till the video number 12, it is already uploaded to the channel. You can go through it and check it. Till the video number 12, we have completed the nitration of amines, electrophilic substitution reaction. And last video under the process, sulfonation. In the case of amines, sulfonation is pending. So that will be also uploaded soon. So you can see this is the first lecture for diazonium salt. Diazonium salt, lecture number 1 by Govind sir. It is written here. So in one video only we will finish the diazonium salt. This is the second phase of the amines chapter, and after that amine will be completed, and next day onwards we will start biomolecule. So be with me. We are going to discuss about the diazonium salt today. Okay. In that case, in diazonium salt, children, we are having diazonium salt. What is diazonium salt? In that case, aryl diazonium salt and alkyl diazonium salt, both kind of salt there, Ar or alkyl. So here Ar means aryl, okay, aryl means phenyl group, R means alkyl, you know, N2 means N2 plus, that is your diazonium. And X minus, that is the interesting part. You are thinking that only halogens are there, but not halogens. Cl minus, Br minus, HSO4 minus and BF4 minus. These species will be on the place of X. So let's talk about the example. C6H5 Cl minus. What is the name of the species? Benzene diazonium chloride. Second example, C6H5 N2 HSO4 minus. What is the name? Benzene diazonium hydrogen sulfate. Okay. So children, in that case, alkyl diazonium salt, alkyl diazonium they are not stable. They are not stable. So we are not going to discuss about the alkyl diazonium. So aryl diazonium aryl diazoniums are stable, but there is one condition. For some time they are stable, for some time due to resonance, due to resonance at low temperature. Temperature should be around 273 Kelvin to 278 Kelvin. On this temperature only, at the low temperature only, they are stable. Otherwise, nitrogen will leave. And this all discussion alkyl or aryl only for 1 degree amine. Alkyl or aryl diazonium salt only formed by the 1 degree amine. So let's check the resonance, children. Okay, so here this is the species: alternate double bond, nitrogen, triple bond, nitrogen. Nitrogen is having positive sign. What happened here? Because of the positive sign, these electrons shifted here and these pi electrons shifted on the nitrogen. So what we are getting? This bond position as it is, this bond position as it is, here double bond, nitrogen, donating electron, then positive sign, double bond, this nitrogen accepting electron, then single bond, then negative charge. In the next step, these electron, wait 1 minute. Here alternate double bond, nitrogen, this nitrogen is having positive sign. So these electrons, because of positive sign, shifted here and these electrons shifted here. So from here we are getting this bond position as it is, this bond position as it is, here double bond, nitrogen, and here nitrogen. This nitrogen is accepting electron, negative, it is donating, then positive. Next step, these electrons shifted here and here positive charge generated. Because of that positive charge, electron shifted. So what happened next? These electrons shifted here, then this bond position as it is, here negative charge, here double bond, nitrogen, positive charge, double bond, nitrogen, negative charge. Now these electrons shifted here because of the positive charge. So what happened next? These electrons shifted here, this bond position as it is, here double bond, nitrogen, double bond, negative sign, positive sign. In the next step, this carbon is getting positive charge. In the next step, what happened? These electrons shifted here and these electrons reverse back here. So what we are getting? This bond position as it is, this as it is, here double bond generated, here nitrogen, and here triple bond nitrogen, and this nitrogen is having positive sign. So these two, check it. So because of this resonance, aryl diazonium salt are stable for some time. So this is the basic information. Once again, I am repeating the content. Diazonium salt, aryl and alkyl, both type we are having. N2 is diazonium. In the place of X, Cl, Br, HSO4, these can be there. Example, benzene diazonium chloride, benzene diazonium hydrogen sulfate. Alkyl diazonium salt not stable. Aryl diazonium salt are stable for some time due to resonance at low temperature 273 Kelvin to 278 Kelvin. This talk is only for 1 degree amine. Resonance here I explained 1, 2, 3, 4, 5. So this is the basic information. Let's go for the preparation. Preparation of diazonium salt. Preparation of diazonium salt. So children, if you remember, in the chemical properties of amines, when we discussed the reaction with nitrous acid, that time we formed this substance. Again I am telling you, C6H5 NH2 plus NaNO2 plus HCl, because we want HNO2, and by this species we'll get this temperature 273 to 278 Kelvin. In that case, C6H5 N2 positive charge and Cl minus generated NaCl and H2O. So this is the formation of benzene diazonium salt, benzene diazonium chloride. Here it is your aniline and it is benzene diazonium chloride. Okay, so this process is called diazotization. Diazotization. Physical property. In the case of physical property, children, they are colorless, crystalline, solid. They are colorless, crystalline, solid, readily soluble in water, cold water. In cold water, they are stable. That means no reaction in cold water. Hot water, they are reactive. They will show reaction in hot water. So these are the physical property. Chemical property. Diazonium salt is having two kind of chemical property. Removal of N2, one kind is removal of diazo group, removal of N2, okay, and second is that diazo group. Diazo group means N2, sustain. Okay, these are the two kind of chemical property that we will discuss. So first discussion based upon the removal of N2. So check it once. So this is physical and chemical property and preparation method. You can go through it once. Preparation method already we have done. Amine NaNO2HCl, because we want HNO3. We want what we want HNO2. That's why then this is your benzene diazonium chloride. This process is called diazotization, physical property and chemical property. So let's discuss about the chemical property. In that case, chemical reactions, two kind of chemical reactions we are having. So first one is Sand-Meyer reaction. Sand-Meyer reaction, and second is Getterman reaction. So both reaction we will discuss, Sandmeyer and Getterman. Here we are having diazonium, okay. In that case, first one, it is reacting with Cu2Br2. Wrong. Cu2Cl and HCl, or you can take CuCl also. Then chlorobenzene formed and nitrogen release. Cu2Br2, HBr, or CuBr if you are using, then bromobenzene will form. In the third case, CuCN and KCN if you are using, then nitrile will be formed and N2 will release. So that is the Sandmeyer reaction, children. Okay. For the Getterman reaction, copper powder and HCl, then chlorobenzene formed, Cu powder, copper powder and HBr, then bromobenzene is formed. So the question is, where is the maximum yield of product? So maximum yield of product by Sandmeyer reaction. Okay, maximum yield of product by Sandmeyer reaction. So once again I am explaining. First chemical property we are discussing, and this is your these are Getterman-Koch reaction. In that case, once again, this is your benzene diazonium chloride, Sandmeyer reaction, Cu2Cl2HCl, then chlorobenzene, then bromobenzene and Cl. Here copper powder HCl, copper powder HBr. By this method, we are not able to form fluorobenzene and iodobenzene. So how fluorobenzene and iodobenzene will be formed, that we have to check. In that case, check it. Here again diazonium reacting with Ki and heat. In that case, iodobenzene is formed, KCl and N2 release. In the second case, this diazonium chloride is reacting with HbF4, then first HCl removed and this species formed N2 positive BF4 minus. If you are heating it, then fluorobenzene formation will be done, BF3 and N2. At the same time, If this species is reacting with NaNO2 in the presence of copper and heat, then nitrobenzene formed. So check it, children. Here diazonium reaction with Ki, iodobenzene form, HbF4, then removal of HCl, then this salt form, then heat, then this fluorobenzenate form. This salt is reacting with NaNO2 in the presence of copper and heat, then nitrobenzene is formed. So almost reactions completed. How to form benzene from diazonium chloride? How to form benzene from diazonium chloride? That we have to check. So how it is formed? Check it, children. Then again nitrogen positive Cl minus reacting with H3PO2 hypo phosphorus hypo phosphorus acid. In that case, benzene will be formed H3PO3 N2 and HCl. These are the byproduct. Similarly, if this species is reacting with C2H5OH ethanol, then also benzene formation will be done plus CH3CHO plus N2 definitely release. One reaction, check it, children. This is again diazonium salt. If you are introducing water H plus OH minus with the salt, then what happened? H plus Cl minus HCl removed, N2 removed, and phenol formation done. Okay, simple for the preparation of benzene and phenol. These reactions we have discussed. So all the chemical property, first type of chemical property, children, completed now. In the next phase, we are going to discuss the second chemical property, reaction involving retention of diazo group, reaction involving retention of diazo group. These reactions are also called coupling reaction. So this is the very important part, children, of this chapter, coupling reactions. Directly they will ask questions from that. So what is the kind of coupling? First, the process is, by these kind of reaction we are forming dyes, different color dyes with different compound. For that you have to, in our syllabus, three kind of dyes we have: phenol orange dye, aniline yellow dye, naphthol red dye. So color also you have to learn sometime. Direct question related to the color, they will ask what is the color of phenol dye, what is the color of aniline dye, what is the color of naphthol dye. So first one is phenol dye. Phenol dye, and the color of phenol dye is orange. Okay. Second, aniline, aniline dye, and the color of aniline dye is yellow. Third is naphthol dye. Third is naphthol dye, and the color is red. Okay. So let's form phenol dye. One mechanism I will tell for the phenol, remaining same, remaining reactions only I will tell you. So simple process. Here we are having phenol. Each carbon is having one hydrogen also, plus diazonium, nitrogen, triple bond nitrogen, and Cl minus. In that case, this Cl minus H from medium is basic. In the presence of base, and pH will be 9 to 10. So from here HCl will leave and coupling will be done. Attachment, disattachment. See, here OH, alternate double bond, and then nitrogen. These electrons shifted here, positive charge vanished. Double bond nitrogen and phenyl group is attached. Double bond, double bond, double bond. So that is the dye formation phenol orange. Phenol orange. It's also called CN coupling, carbon to nitrogen coupling, or diazo coupling or CN coupling. So let's discuss the mechanism. Phenol orange dye mechanism. So check the process. In that case, this is phenol, basic medium I told you, OH minus approach the H and hydrogen electron shifted on the oxygen. So as it is, oxygen is having negative sign. Now oxygen electron shifted here. So these electrons shifted here, these electrons shifted on this carbon. So what we are getting, arrange it. Here double bond, oxygen, these electrons shifted here, then here double bond, here negative charge, and here another double bond. In the next phase of the reaction, now your diazonium salt, here nitrogen triple bond positive and Cl minus. So what happened? These electrons shifted here and nitrogen is getting positive charge. Here attachment will be done and Cl will leave. So what we are getting? 1 minute. So that attachment will be done, and we are getting double bond, oxygen, double bond, and here nitrogen, double bond nitrogen, and here phenol, pH. I'm not writing that whole group, and here one hydrogen is also present. In that case, that chlorine is free, that Cl minus approach the hydrogen, and hydrogen electrons shifted here. If hydrogen electrons shifted here, then these electrons shifted here, and oxygen electron go back. Once again, I am saying chlorine approached the hydrogen, hydrogen electron shifted here, these electrons shifted here, and oxygen electron back. So what we are getting now? Double bond, double bond, double bond, oxygen with negative sign, here nitrogen double bond, and here phenol is attached. So that HCl is formed, no, by H and Cl. So that H plus approach the oxygen, and finally our dye is formed. That is the mechanism. So once again I am explaining. Here phenol, OH will approach the oxygen, then oxygen is getting negative charge, then these electrons shifted here, these electrons shifted here, these electron here, so this carbon is getting negative sign. Then diazonium chloride will came, and these pi electrons shifted here, chlorine will leave, and coupling will be done. After that, chlorine will approach the hydrogen, hydrogen electron shifted here, these electrons shifted here, and oxygen electron back. So this time oxygen is having negative sign, and as it is. Now HCl formed from here HCl formed, that H plus approach the oxygen, and phenol dye formation is done. That's it. Let's talk about the another two dyes and finish the topic. Second is aniline yellow. Aniline yellow color dye. How it is formed? So aniline we have to take NH2 plus diazonium nitrogen triple bond positive sign and Cl minus. In that case, positive charge vanished by the shifting electron, chlorine becomes free, and that H plus will approach the chlorine because one hydrogen is present, and coupling is done. So what is the coupling? This position as it is, and here nitrogen, double bond nitrogen, and phenol. So aniline yellow dye formed. Number 3, beta naphthol. Beta naphthol red. So beta naphthol is what? See, double bond, double bond, double bond, double bond, double bond. Here OH is attached. This position is called beta. This position is called alpha. Then diazonium, same like here beta position, and here phenyl. So that is beta naphthol red color dye is formed. So this way diazonium salt is also completed now. and we have completed the full amine chapter. So kindly go through the channel and check the videos. Any confusion, you can message me in comment box. I will check and reply possibly. So thank you children. Please watch, like and share.